All right, if possible, use the law of syllogism to make a conclusion. If it is not possible to make a conclusion, tell why. Okay, so let me first set this up. You need to have two things here. Okay, you need to have two conditional statements. One, P implies Q, and another, Q implies R. Meaning, you say, if this, then this, okay, and then, well, then if this, then this. That means that if you are able to say, if this is true, then we automatically know that this is true because that's what this tells us is the case. And then we know that that's true because they're the same. The conclusion of this one is the hypothesis of the next one. And if that's true, that leads to this. So knowing this is true leads right to here, which leads us right to there. And so essentially what you can do is you can combine those two into P directly implies R. Okay, so let's look at if that's what we're dealing with here. First, we've got if an animal is a Florida panther, hypothesis, then its scientific name is Puma concolor coriae. Okay, and this one, the next one states now the conclusion of that one, then its scientific name is that. This one starts with that. An animal is a Puma concolor coriae. Then that leads to the conclusion that then it is endangered. Since this one, the conclusion of this one is the hypothesis of this one, we can drop out that middle part and we can say simply, and let me type it here. Let's see, if an animal is a Florida panther, then what? Well, remember, that leads us through its scientific name to it is endangered. So if this, then this, and therefore if this, then this means if this, then this. So we've gone right to, oops, it's a Florida, oh, it's endangered. So sorry, there you go. Just changing colors. Then it is endangered. Yep. The conclusion that we can make when we call it a conclusion, it's not, we don't have any evidence that whatever the thing that we're talking about actually is a Florida panther. But if it was, then we'd know that it was endangered. So in this particular case, the conclusion is really just a new conditional. Okay? So let's do it again. So use that, I'm going to use that same color set and see if it works. Okay? If a line intersects a segment at its midpoint, okay, that's the hypothesis of one, then the line bisects the segment. Okay? And if a line bisects a segment, good sign because we have what is the conclusion of this one. A line bisects the segment is the hypothesis of this one. A line bisects a segment. Okay? Then divides the segment into two congruent segments. Okay? So if a line intersects a segment at the midpoint, that by definition then is it's bisecting it, then the line bisects the segment. And if the line bisects the segment, it's dividing the segment into two congruent statements. Therefore, how do we write it? We would write this as the hypothesis of the first one. If a line intersects the segment at its midpoint, then, conclusion of the last one, then it divides the segment into two congruent segments, period. Okay? The trick with that is the the conclusion of one of the first one, or any one of them, the conclusion of one of them has to be the hypothesis of the other one. And if that's the case, then you can take that part out and just take this hypothesis with this conclusion for your new conditional statement.